Okay. Okay, hello, my name is Pavel. Today I'm going to talk about DAO-controlled decentralized frontends here. So the content of this talk, first we're going to use, oops, it's not showing. It's not mine. Yeah, here it is, okay. So today we're going to talk about central web infrastructure and the problems that come with it. Look at decentralized frontends and how to set them up, compare different approaches of how you can do that. And at the end, I'm going to show a live demo of a tool I built that lets you set up a decentralized website. And if we have some time left, maybe do a QA. So a little about me. I'm Pavel. I work at ENS. Before that, I worked at Fleek as a backend developer. I have a passion for decentralized web technologies that give more freedom to developers and users and decrease the reliance on central authorities. I also do some open source stuff. Here's my GitHub. So let's remember about the issues caused by centralized infra. So in DeFi, there's always been exploits. Most of them were smart contract based, but there were also ones that were surfaced based on frontend. Just in the recent few years, there was a number of attacks on DNS, where DeFi projects had their DNS compromised, or the register got got attacks with the social engineering. Also, 2 years ago, there was an outage at AWS, and it impacted a huge amount of websites, including one of them that was DIDX, which is DEX. They hosted their frontend on AWS, so it suffered an outage as well. So how can we avoid all these issues and minimize the risks of stuff breaking and leading that to your stuff breaking? We can move stuff to global networks. First of all, we should move our files to global networks and host them there, our websites there primarily. Some of them are like IPFS, Airweave, there is also Swarm. Use any storage layer you want. And if possible, don't rely on DNS because it's really central. The register can just take your name and close it and do anything you want, they want with it. Use a blockchain-powered naming system, for example, ENS. There's others as well, but ENS is the most popular and the most common one. And later I'll discuss about putting a multi-sig wallet on top of a ENS domain. So yeah, that's it. And on the right, just like you can see that like a website using an IPFS ID and also like an ENS domain setup. So let's compare decentralized and centralized networks and how in the context of frontend. So decentralized frontend is a website, just files. They're hosted by peers across a network of anybody who just copies your website and also like hosts it. Each piece of content is verifiable because it has a unique ID that IPFS or Airweave gives them. So you can always just locally download the frontend and verify that the website is legit because content ID used on the website, the production website is the same, so it means they're all good. You can also open a decentralized website through a number of gateways. There's no reliance on just DNS. You can open it through an S gateway, through any of the IPFS gateways, Airweave gateways, and so on. Like the only central part here is the gateway, but the content is always distributed and always decentralized. And anyone can replicate it and help you host the website. And you can do it as well. Like you can just set it up on multiple servers, independent from each other. But it's pretty hard to do on central servers because, like, if you want to do a distributed hosting, you're probably going to use a CDN or some sort, which is usually corporate. It's like owned by AWS or some other CDN company, so they manage your stuff. Like you don't have control over it. You can just decide to remove it or anything like that. It's also mutable, obviously, and you can't verify directly. Like there's no hashing mechanism built in to DNS or HTTP. Like you would have to, I don't know, download the website to compute the maybe SHA hash and then just compare it, but it would be not reliable. and there's no replication built in. Like unless you maybe set up some kind of a load balancer or some sort, maybe it would work, but it's like not as straightforward as with IPFS, where you just import the content ID and it just works. So let's go through some of the approaches of how you can set up a decentralized website. The first common is using some kind of a cloud service, then an IPNS that would connect to ENNS name. For context, IPNS is just like a mutable pointer to IPFS, which lets you have like mutable content, which would point to immutable content. So this way, you could only update your ENS once, your domain, to point to your website, and never worry about it again. And the cloud service would deploy and build the website for you. But this approach comes with a number of risks. First of all is that IPNS requires you to have a private key to update it. And maybe you could lose it accidentally or somebody could steal it. But the biggest issue with it is a tiny network. Like unlike IPFS, which is like has nodes all over the world, IPNS is like offered by like 2 companies, I think, and like nobody makes sure that your IPNS files stay on the network. So it's really slow and may take like a few hours for the network to propagate. And also, of course, the cloud service that you're using is obviously centralized because there's no way to like have a decentralized backend like that that would build the website for you. You don't have control over the infrastructure in that case. And you also have to trust that the cloud service stores all the keys securely in encrypted form and so on. And it could also maybe compromise your ENS since you store the private key of it as well. Second approach, we could just ditch both IPNS and the cloud service and just update it directly through some kind of a CI script or I don't know, a local script that just runs the transaction and like builds it manually. But I don't recommend doing that. It's like super risky because first of all, you could accidentally do some stupid shit and just break your ENS and make it point to something else. If you use a CI provider, somehow maybe like there could be just a compromise of the private key. Somebody could steal it and so on. Yeah, but like there is one thing that you could do, like to make it a little better. You could set up a different owner and manager, so that the owner of the domain would be different from the manager. Manager is the address that basically manages the DNS name. And when you have a manager, you could split the access, and only manager would have access to update the name. But then you would still have to have a private key somewhere of it. And if somebody steals it, they also take all your ETH from the manager. And the issue with just updating an ENS directly would be also high network fees because it happens on the mainnet. It would probably cost like around $5, and like if you have a blog with a few posts, updating it every time and paying $5 is a little bit of a stretch. And also, yeah, the private key is might be potentially stolen or something that's gonna happen to it. So what if we just take all the good parts from those approaches and remove the bad parts? And we could do this with the multisig. We could connect DNS to like a multisig wallet, for example, Safe. In short, multisig is just a wallet that is connected to a few other external wallets, and each of them has to sign a transaction for it to get approved. So this removes a problem with where the private key of a wallet would get compromised, and then ENS would be compromised, and so on. There's no such thing because in Safe you have to have multiple parties to approve the transaction. So it removes this risk. So how could this work? There would be like a delegate address. Delegate is a special type of address in Safe that doesn't have access to the main. It only can propose transactions. So, hello, I'm proposing updating ENS to point the new version of the app. And then Safe owner just say like, hello, yes, sure. Or they can just say, no, I don't want to, and reject the update of the website. So in case, for example, if delegate gets compromised, nothing's gonna happen. You just remove the delegate from the list of delegates and reject the transaction and set up a new one. So yeah, this is it. And also in context of DAOs, you could implement a mechanism where frontend would be updated based on the votes. Safe and other multisigs, they implement modules. for DAOs. Safe has a governor model, and based on that, you could, for example, implement a mechanism where, based on votes, for example, 50% of votes say yes to the updates, then the website will be updated automatically. So yes, I haven't seen anybody using it. Like only like a few DeFi projects manually update frontend based on DAO decision, but that's very, very rare. So I would like to present my own project. It's called Blumen. It solves this issue with the difficulties of updating your decentralized website, and also integrates with the multi-sig. So you can set up this whole thing just like with one command, and it will just work. And basically how it would work is you would have a delegate that would offer a transaction to the safe, and then the safe would just approve it, and the ERNS would be updated. And also it supports multiple IPFS providers, so you don't have to re-upload it all the time. Okay, and now it's going to be the live demo. Okay, here it is. So here's the command. Probably nothing is visible here. A little better, not really. So here I just deploy hello world on my Blumen demo.dev on Cipolle network with the safe. Now just deploying. Fetch failed. Well, whatever. I don't know what I'm gonna do. What? Might be. No, it's not dead, but I mean I can show. We just tested before the talk. There was this, yes. Before the talk we tested it, so with another piece of content, it updated the NS from here, from here, yes. So pretend that this worked, like, so yeah, here it updated the ENS with the IPFS hash, and you can see it here in the records. If you open it, it should load, I hope. Yay, there's gonna, yes. So yeah, this is the demo. It's all done through the multi-sig. You can see here, it's just multi-sig, and the transaction was proposed by a delegate, which you can see here. So yes, it's all distributed. There is no central party that would be able to like hijack anything. So yeah, this is it. And if a moment. So if you want to test it yourself, here's the link to the REPL. I'm also on some social networks on Forecaster. And if you have any questions, please let me know. Raise your hand. And that's it for the talk. And beforehand, if you want to ask a question, use a microphone, so we'll hear you.
Sorry, could you reiterate what's the difference between your tool and IPNS?
Sorry,
you didn't use it,
yes.
Right?
My tool doesn't use IPNS because IPNS would require you to store the private keys somewhere, which is not nice, and it's also really slow. So there's no benefit to it that much, to be honest. My tool doesn't use IPNS at all. It just directly updates IPFS. Yeah, you would have to pay the gas, but there is a safe multi-sig that actually executes the transaction. So IPNS is not used at all. It's just direct IPFS updates.
Okay, thanks. And so is your tool free to use?
Yes, it's completely free. It doesn't rely on any service. It's just a CLI that just wraps a few Ethereum APIs and like has integrations for providers. And that's it. Like, there's no server involved.
Mm-hmm. Okay.
No logins or anything.
And so far in the presentation, you talked about, let's say, keeping the website online, yeah, and how's that on the privacy front end? On those solutions, to what extent do they maintain the privacy of the, let's say, service or the hosting party?
I mean, the website is hosted publicly by public nodes. They usually have some kind of like identifier. I'll show it. One of my slides has the demonstration of it. It's here, like to the left. Like you can see, like this is just arbitrary, random services that have like their own ID, and you can see their hostname. Yeah, it's not really private in that sense, I guess. It's all public. It's public infrastructure. So that's the point. The whole point is that like anyone can host any website, and anyone who wants it who can replicate it, and just will contribute to the network and increase performance of the website, increase decentralization. So like if one of the nodes goes down, two others can get their back.
Okay, thanks.
Thank you.
So Blumen uploads to IBFS. What are the current providers that you support?
We have Firebase, which works only on paid plan because they disabled upload to websites because people abused it to oblivion. There's Web3 storage. You can also use your own opinion API if it implements the spec. And there's also Gateway 3, which works the best right now because it immediately shows up like in the content. Because Web3 storage now is very sluggish, but Gateway 3, when you upload it, the website is immediately available. So yeah, those are.
Awesome. Thank you.
Thank you. Anybody else? No. So I guess that's it. Or yeah, that's it.